we need to prove the identity that sin squared theta plus cos squared theta is equal to 1 or identical to 1, as shown here. So let's assume we have a planet in space which is orbiting around a fixed position 0, 0, or maybe a planet orbiting around the sun where the sun is positioned at 0, 0. Or let's just assume we have an object tied to a rope. Let me use a different color from the rope side here. Object is in circular motion, rotating around this fixed position 0, 0, and this object or planet is in two-dimensional space. So let's say at some time or some instantaneous time it is stopped where it is at x in one dimension, maybe x kilometers from the fixed position, and also y, the distance y from the fixed position. Okay, and let's assume the length of this rope is r, and with the horizontal, from the horizontal, the angle is theta. It is theta degrees from the horizontal. So for us to finally arrive to this final identity, we have to derive trigonometrical ratios so that we can use them we substitute them until we arrive to our final solution. So our first identity which we can use is sine theta, since from our equation we see we have sine theta, though it's squared, and we see we have cos squared theta. So for sine theta, we know sine theta, the identity is opposite over hypotenuse. So opposite here is this length, which is y, and our hypotenuse is r, and we do the same for cos. So cos theta is equal to, we know it's adjacent over hypotenuse. So our adjacent here, it's x from here to here, the length x, and our hypotenuse is r again. So we find our trigonometrical ratios. Now we need to link our sides, our length y and x, with r, so we can use Pythagoras theorem. So Pythagoras theorem, we say this bigger side and the two smaller sides. So we have r squared is equal to this is y, this is x, length y squared plus length x squared. Okay, so the final thing which we need to do here is we see here we have y squared and x squared, so we need to substitute y and x into this equation. So we can say this is our first equation, this is our second equation, and this is our third equation. Okay, so the way we can substitute these are the two equations to our third equation is we have to make y the substitute formula here and make x the substitute formula in this second equation. So let's make them substitute formula. So as we said, so sine theta is y over r. So to make y the substitute formula, we have to cross multiply so that we are only left with y on one side. So if we cross multiply, we get y to be equal to r sine theta. And if we do the same for cos theta, so we have cos theta to be equal to x over r. So let's just say over 1. So if we cross multiply again, we get x to be r cos theta. Okay, So we have finally we've managed to express y and x in terms of the trig ratios of the trigs. Okay, so now let's substitute our y and x. So when we are substituting, we have in place of y we substitute with r sine theta, then we square it, plus in place of x we substitute with r cos theta, then we square it. So let's now simplify our expression. We now square it, plus r squared cos squared theta. Okay, so now we have to divide everything by r squared, since r squared is common on every term in our equation. So yeah, this one will cancel, this one will cancel, this one will cancel. So we finally have 1 is equal to sine squared theta plus cos squared theta, and this is our final solution, which of course it's identical. So that's how you derive this identity. Thank you.